Okay, so we got this situation. If this is divided by 7, then the remainder is, okay, let's apply this concept. So we will solve this question by traditional method so that you can have conceptual clarity as well. If you will observe, in numerator we have 27, correct, and in denominator you have 7. So clearly numerator is bigger than denominator, correct. So under this case what we should do, we should write 27 as multiple of 7, means start using table of 7 and get closer to 27. So 7 4 times 28, and 28 is most closer to 27. So can I write 28 minus 1 power triple nine? Just tell me, है ना? So look at this part. Let's expand 28 minus 1 power triple nine. Okay, let's open this bracket. So you know that it's a binomial thing, so we can apply that concept. So triple nine C 0, we will have 28 power triple nine and minus 1 power 0 plus triple nine C 0, sorry, this time C will be 1. Okay, the lower subscript of C will be 1. 1 28 power 998 minus 1 power 1, correct, and this thing will keep on going. Okay, now at the end what will happen? Triple nine C triple nine, and this time 28 to the power will be 0 and minus 1 power triple nine, correct na? Now before that you will be having 999 C 998, and then you will have 28 power 1 and minus 1 power 998. Okay, and we have to divide this thing by 7. So don't you think that this element will be completely divisible by 7, because it contains 28 and 28 is divisible by 7. This element will be completely divisible by 7 as it contains 28. Okay, so what I feel is the element in which 28 will be present will be divisible by 7. So in which part? Now look at the second last term. So here also 28 power 1. This means this is also divisible by 7. So the only person which will be left alone is the last member. So who is the last member? Last member is triple nine C triple nine minus 1 power triple nine will be left alone, which is not divisible by 7. Now triple nine C triple nine is 1, minus 1 power odd, so it is minus 1. So if we will divide 27 power triple nine by 7, we will have remainder as minus 1. But you know that remainder cannot be negative. Now look at this. Suppose that I want you to divide 10 by 3. Okay, so if you divide 10 by 3, you know you can write 3 3s are 9, so remainder is 1. So you know that clearly remainder is 1. Suppose that I am doing the same concept, but I want to write 4 over here, so it will be 12, so it is minus 1. So can I say minus 2 will be the remainder? You can also write minus 2 as the remainder, but you know that in reality remainder is 1. So how we will get 1? You have to add these two elements, means we have to add the negative number with the number to which you are dividing. So required remainder will be what? Minus 1 plus 7. This means 6. So 6 is the remainder. Okay, I hope you got the idea. Now look at this. I have told you about Fermat-Little theorem. Okay, do you remember that concept? Over there we have a restriction that we have to divide by, wait, 27 power 999 upon 7. So look at this, the number by which you are dividing is a prime number, so it is a prime number. So you know that if you will write 27 power 6 by 7, you will have remainder as 1. Correct or wrong? Okay, so let's write down this 27 as the power of this. So can I write 27 power 6 and power, look at this, what I am writing, I'm trying to break this 999. Okay, so 6 1 times 6, we have 3, 6 6 are 36, 6 6 are 36, and we are left with 3. So can I write 27 power 3, or can I write this thing as 27 into 27 into 27? Correct? So we have to divide this by this and we have to get the remainder. Now look at this. Can I interchange these two things? This means 27 power 166 power 6. Okay, and then divided by 7. You have 27 27 27. Correct? Now be super slow. You know that this number when divided by 7, the power is 7 minus 1, 6. So remainder will be 1. So from this case, remainder is 1. Okay, and what we will get as remainder if we will divide 27 by 7? Okay, so 7 fours are 28. So 28, 27 minus 28 is minus 1. So we will get minus 1 from here, minus 1 from here, minus 1 from here. So we got 1 into minus 1 into minus 1 into minus 1, which is minus 1. So remainder is minus 1. You know that remainder cannot be minus 1. So required remainder will be what? Remainder will be minus 1 plus 7, that is 6. So remainder is 6. So using both the concepts, you got the same result. Okay, I want you guys to have command over both the concepts, because sometimes Fermat-Little theorem can help you a lot. Okay, I hope you got little bit of clarity. Let's move on to other illustrations so that we can develop better understanding about the topic. Okay,